Energy, check. Space, check. Projectiles, check. Shoutouts, check. Start electricity, check. Like and share. I can't check that one off yet because we're not liking and sharing National 5. We need to like and share Mr. Bull's Physics because we're on 149 subscribers and we need to get to 200 by Christmas, and that's only going to happen if you guys like and share. We've got so many people who are already subscribed, and today I'm just going to shout out and I'm going to actually salute these people because they are the people who are subscribed but don't even study National 5 Physics. They are doing it because they just want to be a part of the wider family. And I'm telling you, I know these people personally and they're following this channel, and so I want to give them a shout out. Shout out to a nurse who is following this channel. I want to shout out to a medic student who is following this channel. I want to shout out a creative entrepreneur who is following this channel. And I also want to shout out someone who's working in Apple who's also subscribed to this channel. Guys, these guys are leading the way. So if they can do it and they're learning about National 5, those who are sitting National 5 should be subscribing and clicking subscribe right now. Okay? So I'm not going to say any more about that, but please like and share and subscribe. Right. Anyway, less of that. We're going to be talking about Q equals IT. Alright? This is going to be a very short lesson this week because we're only going to be looking at a tiny bit of the course. And this is this equation here, Q equals IT. Now Q equals IT is charge, and we talked about charge last week, in coulombs, in C, equals current, which is measured in A, or amps, and time, which is measured in seconds. This is an easy equation. Guys, D equals VT is the same as this. It's just Q equals IT. So the way that we change it and manipulate it shouldn't be that difficult. Alright? So let's just do a wee quick example. Q equals IT, let's just see how easy this actually is. So if I take this here, and I do this, and the question says 40 coulombs of charge pass through a bulb in 50 seconds, calculate the current. So I know if I do a wee triangle, I have Q at the top, I, and then I have T. So if I want current, cover the current, Q divided by T. So I equals Q divided by the time. That's going to be 40 divided by 50 gives me 0.8 amps. That's pretty easy. I'm not even going to continue talking about that because that there is simple stuff. The start of electricity is a really good way to get your head around some of these easy equations and hopefully get you a little bit of confidence into this course. Alright, so anyway, I'm going to get rid of the pen and I'm going to move on. The only other thing I'm going to talk about, and I said it's going to be short, this is short, is alternating and direct current. Now, alternating and direct current have this battle going on between Thomas Edison and Nikola Tesla. Nikola Tesla came up with AC and Thomas Edison came up with DC. Alright, so there's a difference between the two different electricities. So if you have time, I'm going to put this purple on, watch it and see that, that battle take place. Now, we know that there's lots of different things with DC and AC. And there's lots of information here, but essentially AC is something that, as we read here, electric charge periodically reverses direction and is transmitted to customers by a transformer that can handle much higher voltages. Essentially, we use AC for much higher voltages. For example, if you plug something into the wall, that's AC. If you have an appliance, that's AC. Anything that you plug into a wall is AC. So we use AC all the time, but you also use DC all the time. And it says a flow of electricity is the one direction only. This system operates the same as high voltage level throughout and is not efficient for high voltage. So things like your phone use DC. Things like remote controls use DC. Everything with a battery basically uses DC. So, what can we say? The indirect current. In a circuit with a battery or cells, the current travels in the same direction at all times. So it constantly goes round in the same direction through the circuit. Alright? This is called direct current. So if we were to say that, that would be this constant line of voltage. Now, if we had alternating current, we actually find that in things like main supply is that the electricity is kind of going back and forth, like a sine wave, right? Going back and forth. Now that means that our model of something going round the circuit doesn't make sense if it's going back and forth and yet there's still electricity. So this is where electricity gets a little bit weird. And actually when you realise it, you have to go to university to really understand this stuff. Now, what do I want you to take away from this? Okay? Well, there's a couple of things. One is that because we have a wave for the AC, we can actually find out that the main supply has a frequency of hertz. Now remember, frequency is the number of waves divided by the time. So because we can have an AC, which is a wave, we can say that it has 50 hertz for a main supply, which means 50 waves passing a point every second. We also can say that the main supply has an average of 230 volts. That's something you might need to know. 230 volts. Alright? And if we were to actually just put it on a page, the direct current, as we said, is constant. Alright? Batteries provide a direct current, it's constant. And you see that the voltage is the same. Okay, all the way around. But alternating current has this wave and it changes back and forth. Okay, and it has quoted value of 230 volts with a frequency of 50 hertz because it's a wee wave like that. Alright? But all you need to know is DC is a constant current and AC is one that changes. Okay, back and forth. And Q equals IT. That's all I'm going to be talking about today. Okay, just a wee short one to keep you going. Alright? So my final thoughts. Today is a day where we are going into a new tier system. So whatever tier you are going into, I just want to give you encouragement that we will get through this National 5. There will be a day where we do not have to not shake hands, where we don't have to avoid people. We will be able to embrace people. So I just want to give you encouragement, keep on going, because there's always, always hope. National 5, always hope. And my friends isolated know about that hope. Alright, so guys, tune in to next week, electricity, and moving on to probably Ohm's law, okay, which is a very, very important one. See you later, National 5.